morning, everyone, and welcome this morning to the first session, second day of Innovation Forum. It's my pleasure to open the second day of Innovation Forum with, I would say, a very interesting topic, the one dealing with sustainability of the hydrogen and the circularity of different technologies. My name is Claudiu Pavel. I'm one of the project officers at the Clean Hydrogen Partnership. We are going to have 1 hour for the first session. I think you had a very good time these days in Brussels. Today is a special day. We saw the sunshine outside, so things are getting better. And thank you for coming. I know it's a bit too early maybe for some of you. But I promise we had a very good and interesting debate on a very interesting and important topic. To put a bit on the perspective, the hydrogen sustainability and circularity, I think everybody agrees in this room, and not only around all other exhibitions, that Europe now is on the way. On the decarbonization, the hydrogen will play definitely an important role in different sectors, in particular those that are called hard to debate. But still the question remains, and this day, at least myself, we heard many times some keywords: innovation. We heard about scaling up. We heard about sustainability. But what does it mean in the end, sustainability, I would say? There are definitely few challenges that needs to be tackled, in particular when the technology will go at a certain mass scale, I would say. And this is the question that with our panelists we'll try to address today. And on my side, I will start with a very short presentation to bring some of the activities that the Clean Hydrogen Partnership is working in the field of sustainability and circularity. But let me start again with some points that we see possible issues when these technologies will reach a certain mass scale. We can bring along different areas of the pillars of the sustainability, but as well on the circularity. Some of them can be linked to the techno-economic. The technologies are still not maybe at the top of what regards the efficiency. They are costing pretty a lot. On the environmental side, many of the technology are still relying on, for instance, what we call forever chemicals, such as PFAS, but as well relying on a large amount or very critical materials, critical raw materials. Another situation are linked as well to, depending on the audience, on the water possible limitation or water availability. Regarding the society, I think there are still some concerns about the safety. This is one point where people are not fully aware what does it mean or having the hydrogen technology in their backyard in different ways. Circularity is definitely important, and this will be not only in managing the waste during the manufacturing, for instance, but as well dealing with the end-of-life products. We have shown these maps several times yesterday and the first day of Hydrogen Week. It's not my purpose now to call and to mention all the technologies that in the Clean Hydrogen Partnership we are dealing with. These are part of our strategic research and innovation agenda. Our ambition is definitely very high. As you can see, we are trying to deal with most of the technology across the hydrogen value chain. In terms of sustainability, I think there is a kind of focus in what we call horizontal activities, either dealing with the cross-cutting or with the supply chain or even strategic research challenging. What I would like to bring your attention is a bit on a mapping exercise that has been recently carried out with a group of experts within the European Hydrogen Sustainability and Circularity Panel. The idea behind this exercise was to have a kind of baseline to understand how our projects and the core topics were addressing the sustainability. along different indicators. 9 indicators have been put in place. I think we can observe a positive trend compared to back in 28, 29, when, for instance, for the same number of projects, 28, if I can bring a reference, projects, the overall number of indicators were around 40. This number has definitely increased for the same number of projects last year, where the indicators addressed were over 100. If we look to a map of aggregated indicators, we can see that the most addressed indicators, is not surprised, I would say, is the economic one. Basically, 1 out of the 2 projects is looking at the economics, reducing the capex, reducing the cost, followed by environmental indicators. And towards the end, we see a bit on the materials criticality, circularity. Our projects are putting less effort, I would say, but this is coming as well from what regards the core topics. A very large pool of over 350 projects has been scrutinized, and this analysis is not including the hydrogen valleys. This is the situation for what came from the hydrogen valleys projects. 16 hydrogen valleys are nowadays in place. The results are as well very clear. Basically, most of them are looking at the economics, environmental, and the same kind of conclusion. Less are addressing materials criticality or the circularity. Over our previous mandates of the partnership or joint undertaking, overall we funded 373 grants by now, and to some extent they all are looking on advancing the sustainable hydrogen ecosystem. We can bring these activities in different sub-chapters, if it's about innovation, dealing with innovative technologies, if it is about cross-cutting activities or strategic research challenges or hydrogen valleys. Very quickly to sum up some of these activities, we put, I think, continuous effort in lowering the amount of CRM, PGM in particular, from the technologies, in particular from the fuel cells technologies. Nowadays, we are in the place to hopefully to start early next year new projects looking in the gap phase and the grant agreement preparation phase in removing the PFAS, looking at PFAS-free polymers for PEM technologies in particular, and as well looking at direct seawater electrolysis. We have activities dealing with recycling, eco-design guidelines, life cycle assessment, regulatory safety, and so on. But apart from the grants, we are dealing as well with different other activities. More relevant is the early established group of panels are acting all together in the European Hydrogen Sustainability and Circularity Panel. I will talk a bit more about that. We are enjoying a very good collaboration with our colleagues from the European Commission Joint Research Center, and based on their expertise, they are helping us a lot on defining guidelines, or they are looking as well at many reports dealing with the LCA and not only. We have carried out as well some studies. More relevant is a study on sustainable supply chain, for instance. Another ongoing, and I think is still open for tendering, a study that we like to see if the impact of water consumption and the impact of water availability, and as well we are involved in different workshops. I will take another minute to introduce some of our what we call strategic research challenging. So far we have 3 projects. They are dealing with the concept to generate long-term research knowledge that can help different technologies across hydrogen value chain. The relevant one is a project that goes back, let's say, in the laboratory, trying to understand the degradation mechanism that will allow to increase the lifetime of the electrolyzer. We have another project dealing with development of advanced materials for hydrogen tanks hydro, the previous one is electrolyte. And another very relevant project is the Sustain Cell, looking at sustainable supply chain, trying to close the loop from looking at sustainable materials, testing them, dismantling the cells, and putting back in the system. Briefly about our new group of experts gathered, as I said, in the European Hydrogen Sustainability and Circularity panel. We have 15 experts working together, helping the partnership to understand those areas that maybe we're not looking or we're not focusing so much, helping us to integrate different elements in our program and as well in the core topics, and as well trying to share outside the organization and within our organization the knowledge. I will conclude with some of our achievements. This was a very difficult task because it's very difficult to bring everything in one slide. Few points I would like nevertheless to mention here. I think we have done so far a lot of work, and there are very good results for regards the advancement of the electrolyzer. A pretty important share, let's say, of the installed capacity have been supported by the GEO projects. Regarding the storage, in particular the underground hydrogen storage, we had as well different projects looking at understanding the geochemicals behavior, but as well to see if this technology is publicly accepted, overall building what we call a kind of confidence in underground hydrogen storage across Europe. I mentioned about reducing the PGM, and this effort has been done in particular for the fuel cells. I think the platinum overall loading has been decreased by 10 times in the last decade. Focus now is towards reducing, for instance, the iridium from electrolyzer, from PEM electrolyzer and other critical raw materials, including the PGM. We have advanced, and I'm glad to see some of the project coordinator for as regards material recovery, very high rates for platinum from PEM fuel cells. In terms of hydrogen mobility, I think we did as well some work on increasing the public acceptance, different bus roadshow across Europe. The last but not least, I mentioned about the LCA efforts on the education, public awareness. We have developed some guidance for the LCA assessment together with the effort put by the colleagues from the GRC and other elements in this area. I will stop here. As I said, we have another 50 minutes or a bit less to discuss about this topic. Focus will be on the challenges related to the making hydrogen technologies more sustainable and as well dealing with the recycling. It's my pleasure today to introduce my co-moderator, actually, Professor Javier Dufour. Maybe welcome him with a nice applause. And Javier actually is playing and is helping us pretty much. He's one of the members of our sustainability panel. He's helping us in defining the core topics in the technical assessment, and it's very, very nice to meet you. So, Javier.
Claudiu, it's working? Okay. I would like to invite the panelists here, and please welcome all of them. We have first Jesse Walker, please. Deborah Jones, Eugene, McKenna, and Isotta, Cerri, please join us. So I think that we can begin because I think this is a very interesting topic. I would like just to raise some questions to you. For instance, I think the most important one is which is the role of sustainability and circularity in the deployment of hydrogen technologies, because I think that all of us are convinced that hydrogen is key to reach the carbon-neutral society, but there are some other challenges in this sustainability and circularity. What do you think, please, James? Mm-hmm.
Thank you for the question and the invitation to be here. It's great to join you this morning. Good to see such a big audience, given we're in the first session. So I'm James Walker. I'm team lead for renewable gases at IRENA, or the International Renewable Energy Agency. And for anyone who doesn't know us, we're an intergovernmental organisation. We serve 170 member governments, including the EU in their own right. And our function is to provide analysis and guidance to those governments about how the energy transition is progressing, the role for renewable technologies in driving that forward, and in particular, in my case, thinking about hydrogen and the derivative sectors, and their role in the hard-to-abate sectors, as we've heard in detail. So on the sustainability topic, I think I'm glad I get to go first, because it's quite an obvious statement I can make, and then perhaps the colleagues on the panel can give a bit more detail. But for me, the conversations we're having are all about sustainability. It's inherently intertwined and essentially woven in as a component of the development of these sectors that we're interested in. We're not here for any reason other than, well, I'm certainly personally not here for any reason other than delivering a sustainable future. So it's essential that we are accounting for all of the parameters that have been mentioned already at the very beginning of the evolution of these emerging sectors. And that's the driving theory and driving focus behind our work. So we're really working with those governments and other stakeholders to think about how we design a sustainable hydrogen economy, rather than reverse engineer it once it's up and running. So in our work, we are really very firmly aware of the importance of international standards in helping to set the scene and give guidance to government stakeholders, particularly industrial organizations, in what is accepted or understood to be sustainable across the various parameters that have been discussed. That starts with life cycle assessment of emissions, but it's certainly broader than that. We have a really important role for safety standards, as was mentioned. Water is a real challenge in many of the geographies that we know will be important for the production of hydrogen and the derivatives. So we need to see the right kind of standards on water and good innovative approaches to managing water constraints as examples. I think that's probably my first reaction. I'm interested to hear what the others think.
Oh, thank you. And Deborah, please introduce yourself and address the question.
Thank you. So thank you very much for the invitation to be here. Very glad to participate in the panel. My name is Deborah Jones, and I'm a research director at the French National Research Organization, CNRS, working in our laboratories in Montpellier. So as a research organization, we have large teams of researchers who are working in hydrogen technologies, around about 300 full-time researchers, along with teams of postdocs and PhD students who are working on these topics. In 30 or so different laboratories, working on topics right the way through, from materials developments all the way through to their implementation, testing, diagnostics, modeling, through systems analysis and systems development as well. So of course, as a research organization, then sustainability and circularity aspects are being taken into account more and more in everything that we do. I was extremely interested by the analysis that was done that Claudiu showed us there on the increasing position that's taken by topics such as criticality, sustainability, in the consideration of all the various projects that are being funded. And certainly agree that in 20 years or so ago that some of the justification for the work was on an economic basis, and increasingly the emphasis and the justification and our objectives are replacing, reducing, substituting, increasing performance to get the maximum from the materials that we're using. And this in collaboration, of course, with our industrial partners. So, I mean, just as one example, even if we look at PFAS, and I'm sure we'll be talking about PFAS again in this conversation, but even if I look back to 20 years or so ago, then the argument for replacing Nafion or other perfluorosulfonic acids was more in terms of cost. In fact, that substitutes for naphthalene would be cheaper. They might have different technical performance as well, but would be cheaper. And now, of course, the conversation is quite different.
So thank you, Deborah. Please, Eugene, introduce yourself, and because I think your company is going to play a key role in recycling our materials. So please, go ahead.
Okay, well, once again, thank you very much for the invitation to be here. It's fantastic always to be at EU Hydrogen Week and meet so many people who are trying to do something rather than, we're doing a lot of talking, but there's lots of people here who are trying to do something to make the energy transition happen. So Johnson Matthey is indeed, considers itself to be at the heart of the energy transition. It's an old company, platinum group metal company, and it's really used science to innovate that base on platinum group metals into a variety of businesses over the last 200 years. So a lot of that's being involved in the rail economy, so clearly fossil fuels up until this point. But now we're pivoting to try and catalyze that energy transition. So we have interests in, first of all, in green hydrogen. As a platinum group metal company, PEM electrolysis is the interest. So we make catalysts and membranes, PFAS membranes, and catalyst-coated membranes for PEM electrolyzers, also for fuel cells. We have a big recycling business, so we're the biggest recyclers of platinum group metals in the world, so that will come to the circularity discussion as well. And we also have the chemical toolkit to make hydrogen, so blue hydrogen from fossil fuels, but also to use the hydrogen in making things like e-methanol, e-ammonia, cracking that ammonia back to hydrogen, sustainable aviation fuel. So kind of that chemical toolkit to make things happen. So in terms of sustainability, it's, as previous speakers have said, it's the whole reason for us being here. I often, looking a bit of an interest in the history of energy over the years, and it's really evident that until we started using fossil fuels, the life of the average person pretty much stayed the same from the Bronze Age until the discovery of fossil fuels. So everything that we have in terms of enhanced well-being, health, educational opportunities, all of it has been fueled by fossil fuels. And so the trick that we need today is to remember the last part of that, which is sustainability. We've bumped into the sustainability wall. We've forgotten the effects of fossil fuels that we need to deal with. Everything, so we've now got to deal with the sustainability aspects of this, but without crushing the attempts that we're making to go to the energy transition. So that's the challenge for all of us, because we're all interested in recycling and in bringing in more legislation to make this happen. How do we do this while making the energy transition happen?
Thank you, Eugene. Please, Isotta.
Good morning, everyone. My name is Isotta Cerri. I'm from Toyota Motor Europe. Just to short introduce myself, we are based here in Belgium, Brussels. We oversee the design and manufacturing of vehicles that are sold in the European market. As material engineering, my division has 3 areas of responsibility, going through the very low TRL to the very high one. In the very low one, we are doing advanced research for sustainable and clean technologies, fuel cells. We've been working on this technology for 20 years now, focusing on polymembrane, electrode, fuel cell separator, the hydrogen tank in the design, carbon fiber, always trying to reduce the cost, increase the performance, the durability. Next to fuel cells, we also work on batteries, liquid and solid, photovoltaics, perovskite-based, and more recently on the electrolyzers, PEM fuel cells, PEM type. Next to these also we have a number of technologies to capture and convert CO2. So as you see also in advanced research, a lot of sustainability topic. The second area of responsibility is mostly linked to the localization of our material supply chain, and considering the hybrid model, we localize those materials for the electric power unit, like the electric motor. And the third area of responsibility is really development, assessment of materials going into our European vehicles. That means paint, metals, aluminium, steel. So we talk about green steel, it's very important. Again, sustainability, plastic, recycled plastic, more and more. So in all these three areas of responsibilities, we really see that the circularity and sustainability are key drivers for development. So now, coming back to hydrogen, what I think is the role of sustainability and circularity, I have to share the same views of my panelists here, co-panelists. It's becoming more and more important, crucial. Sustainability is green hydrogen. Now everyone believes that this is necessary for fuel cells. So it means it should be available and cheap. PFAS, with a ban that might compromise the use of fuel cells, so we need to look at alternative. I agree with Deborah. 20 years ago, together in a European project, by the way, we were looking at alternative technology for cost. Now we have to look at back. So I do hope that the Clean Partnership invests more in this area. Regarding circularity, we need to recover those critical raw materials, platinum or iridium, depending on the technologies. Separate the monomer to recycle, not to impact the environment. The carbon fiber for the hydrogen tanks, we would like to have continuous long fibers recycled to utilize again. So there is a lot to do. They become more and more important and also critical, because this business, in my opinion, is not yet mature and stable to just afford the second cycle of development of new materials without support. So we need really support, and we need to work together for that. Thank you, and thanks for having me here.
Thank you so much for your comments. So, several topics, several areas has appeared about sustainability, critical raw materials, water use in water escapes areas, PFAS, and so on, but also circularity, because we are talking about circularity, but one of the key points for a circular economy is recycling. And this is one of the pending questions on the hydrogen sector, because it's not really well developed. Okay, processes are there, but there are, let me say, there is not enough volume of products to be recycled, but we need to develop this process in advance to be a very well developed economy. So I think you have to leave earlier. Isotta, perhaps you can begin just saying what do you think about this, about recycling, circularity, and so on.
Of course. So for circularity, you just mentioned recycling of precious metals. I think one of the challenge is to separate, for instance, for fuel cell from the polymer. Now we have different stacks on the market, maybe different polymers, so also sorting, and the technology for separation might be complicated. But so we need investment here. As I mentioned again, the carbon fiber for the tank is another aspect. We would like to be able to, in the carbon fiber reinforced plastic layer, we have a thermoset, so you cannot easily melt. So you need to develop some solutions to be able to separate the fiber from the plastic already. And then the fibers are ideally not chopped as it's done now by shredding the tank, but continuously and keeping the same strength. So there are a lot of technology needs, but this is just for specific recycling. When we talk about circularity, we have to think about the durability. We want to have products that are durable for a longer time than now. So also this part of design is very important, and design eventually for dismantleability, because in a stock at the moment you cannot take out a cell, check, evaluate if you can reutilize, second life, or remanufacture, repair, utilize, or eventually recycle. It should be the last option. So I think it's important to also consider design for disassembly. And when we talk about disassembly, automated disassembly, like we do now for manufacturing. So it's a bit broader than just recycling, but there are a number of needs in this area.
I agree. I think the eco-design has to play a key role for circularity, because we need to design for disassembly, but also to minimize all the impacts along the full value supply chain of this product. But perhaps, Eugene, your company is a reference in recycling. I think you can give a more realistic view.
So I think it won't be difficult to sell the idea at this venue that recycling and circularity is very important. And it's a very laudable thing. And if we think of the end point that we get to when we've been through the energy transition, there will be hugely more recycling and reuse and design for recycling. And as that occurs, we can build in more legislation to make it essential. So it's also important that it does not crush the early stages of the industry as we go along. However, in this business, there are some aspects of recycling that it will really be helpful at the start if we think about them from the start. Thinking of PEM electrolysis and fuel cells to begin with, it's important to pan out and look at the big picture, because this isn't just a cycle, it's a system and a web of overlapping circles that are going to have to operate and to make this work. So if we think of the hydrogen that's going to fuel the fuel cells and the energy transition, a lot of it has got to come from renewables that are intermittent. And we want to balance out those intermittent renewables. We need some way of storing that energy. And a really good way of doing that is electrolysis, and it's PEM electrolysis is the technique that's most useful. Why PEM? Because you can connect it to the intermittent. The other technologies do not like being connected to energy that goes up and down. In order to do that PEM electrolysis, first of all, we do need PFAS membranes at the moment, and we can come back to that, but the fluorine at the moment is doing an important chemical job, and we can't just wish it away until we work out how to do the chemistry a little bit different. But thinking of the catalysts, iridium is crucial to that, into that reaction at the moment, the oxygen evolution reaction. And at the moment, iridium is a really rare metal. There's 7 tons of it mined a year. That's a 60 centimeter cube. You can imagine a ton of a year of it going into this application, which is a 30 centimeter cube. And it's got to be spread out over 20 football pitches of membrane, put into applications for 8 years, and then we've got to get it all back again. People often worry about there being enough, but as long as we get it back, there is enough. But it won't be recycled just by leaving it to the market. So designing this and compelling this to happen right from the start is really important if we are to get the hydrogen that we need to go through the energy transition. Another kind of linked bit to this is that iridium is not mined on purpose. It's mined along with platinum as a side material from that mining of platinum. And at the moment, platinum goes almost, the biggest use case is into automotive catalytic converters, and we're going to hope that those go away as the internal combustion engine goes away. But the next big use case is in fuel cells, and the fuel cells will create the market. I know we're talking about minimizing the amount of platinum group metals, but unless we get platinum going into the fuel cells, there won't be the investment in the mines that produce the iridium that will produce the hydrogen. So as long as we get a little bit of penetration into fuel cells, then we will have the hydrogen that we want to use elsewhere. So I guess something else I'd say is all of this ability to recycle already exists. It's not like the other critical raw materials. There's already an existing network for recycling. And Johnson Matthey, actually, we've just developed a process for cold recycling of CCMs. So we can recover the catalysts and recover the membranes and the ionomers. There is an issue about different ionomers, and of course that's something else that we might need to regulate, otherwise we'll need to keep them separate. Just to leave it there, but to give that as an indication of how sometimes recycling will be nice to have and it will always improve things, but for the evolution of the business that we're looking for, it's actually essential in some areas. We can design for it, and the time to design for it is now, because clearly there are economic factors that could encourage people to design not for recycling because it may be cheaper in the first instance to design to throw away. And those who think about designing to recycle will have better economic outputs and outcomes in 8 years' time.
So thank you. Deborah, from the point of view of research.
Perhaps, just pick up perhaps on what Eugene just said, and if you can imagine that something like 100 tons of platinum are presently used in internal combustion engines, and then it's an easy calculation to see what part of the market that heavy-duty vehicles, light-duty fuel cell vehicles must then take in order to create the conditions that platinum continues to be mined. And investment is needed because shafts become mined out, and new investment is needed to create the conditions for platinum that will ensure that iridium is also available as well. And so recycling, of course, and you know, the design of the materials to enable that recycling. But I'd like to come back to something as well that Claudiu referred to in his presentation, and that's the enormous progress that's actually been made in fuel cells in reducing platinum loading, or increasing, let's say, you know, the kilowatts that you can get for each gram of platinum that you use. Because it's not only about platinum loading, really, it's also about the whole fuel cell or membrane electrode assembly and the materials and how they're put together that actually allows that increase in performance, which then allows you to get more kilowatts for every gram of platinum that you put in. So that's been done progressively over the years, and I'm thinking of projects that we've been involved in with our project partners, including Johnson Matthey, such as Volumetric, Inspire, Gaia, more recently Highlander, where we are reaching the targets in terms of platinum loading for the fuel cells, the SRIA targets for platinum loading. And to come back to iridium, then really a similar effort then has to be done there. And when I look at research that's being done, there's really more that can be done. 1 megawatt electrolyzer will need, with 1.5 milligrams of iridium per square centimeter, something like 200 grams of platinum at the 400 grams of platinum at the present, iridium at the present time. But there's progress that's been made that's actually reduced that by a factor 6 already, which means that you don't need 400 grams of iridium anymore, but you need 60. But that's not enough. Further research needs to be done, not only on reducing the loading, but improving the performance altogether of the assembly of the cell, assembly of the materials involved. Reducing the membrane thickness is another way forward. So in addition to the recycling, which is absolutely essential, we also need improvements in materials and in the design, which will also allow us to get those gains.
Well, thank you, Deborah. From the point of view of IRENA, this large entity organization, so how do you see the development of recycling in the future? Because
thank you. I think we've heard from the technical experts, so I'll try not to reiterate anything that's been said. I'll maybe just share a short reflection. I think reflecting on Isotta's examples of some of the real technical challenges and some of the, I guess, research and innovation needs, my position here means I can take a slightly different view of what that means and say that's a huge opportunity. We can look across the value chain and see an opportunity for innovative organizations to be coming in with solutions to deal with exactly that problem. And that's really how we move from a position of discussing an extremely investment-intensive challenge for all of us who want to see this sector come along, and actually look at it as an opportunity for industrial development and for job creation and skills development and so on. So I don't have anything to add on the technicalities, but I think if we frame this as an opportunity as much as it is a challenge, and recognize the vital role for research and innovation in bringing forward the solutions we need, then I feel quite optimistic.
okay, thank you. So time is flying. We have almost 15 minutes just to finish. I would like to have some time to get questions from the audience, but I would like to just to pose a new question, because we are talking about sustainability, but sustainability also includes the social pillar. We have to minimize the social impacts along the supply chain of these hydrogen technologies. Also, just combining environmental, economic, and social, I think that research has to play a role, but not just from the scientific or the engineering point of view, but also from the social science. So I would like to have just a very quick answer on this. How do you see the role of research, not just in circularity, it's just approaching the whole sustainability, and also how the Clean Hydrogen Partnership can help to the deployment of these hydrogen technologies, but based on sustainability and circularity? So quick comments. I don't know, James, if you want to.
Thank you. So Claudiu, you mentioned confidence in your presentation, and I think confidence is the word of the day. We need to be building confidence across the value chain and out in society in these technologies, helps drive investment. You might hear I come from Scotland, and almost 10 years ago, I stood on the first hydrogen bus that was deployed in Aberdeen by the Forerunner, the FCHJU at the time. And those buses have been running and people have been getting on them and not really thinking about whether or not they're standing on a fuel cell bus. I think that's a real success story of applied innovation, and we've obviously seen fleets deployed in other cities and other communities having that experience. We also see technologies having been deployed across the value chain. So I can zoom out a little bit and say that these applied innovation projects are such a critical part of showing the path forward, showing how these systems can actually evolve and what happens when we put the investment in at the right time to support that. So I think it's all about showing the future and bringing everyone with us as we do.
Thank you. Deborah?
You asked about the role of research. You won't expect me to say anything else than that the role of research is absolutely crucial, of course, but also we have the massive advantage in Europe of having the private-public partnership, which is the Clean Hydrogen Partnership, and the involvement of the two communities of research and industry with the opportunity to work together according to the various annual working plans. And so, of course, sustainability and circularity are topics that must be built more into these annual working plans. And here, the new panel on sustainability that Claudiu mentioned, you're involved in, and here, I think there's a huge role to be played in actually advising and ensuring that those topics have the space that they need, so that sufficient research is actually associated with those topics, and we have this. Breakthrough innovation that we need in these topics and integrating sustainability and circularity from the very beginning.
Thank you. Eugene?
Once again, I think you'll find another fan of innovation here. I mean, I think innovation is at the heart of what will get us out of the mess that we've got ourselves into. It's the only way that's out of the mess and actually implementing things. I think in the GEM, we spend more than 200 million euros a year on R&D, which through open innovation and partnership with people like the Clean Hydrogen Partnership, we aim to multiply the benefit that we get out of this. Actually, the two organizations that are involved in this, think of the panel that's thinking about the sustainability and the circularity along with the Clean Hydrogen Partnership, really working cooperatively together, can bring together that hard innovation focus together with that broader sustainability, not just in terms of circularity and carbon footprint, but all of the social aspects of sustainability as well. And I think that there's a real opportunity for synergy between those two organizations thinking the way forward, while always remembering we've got to actually do stuff and not think of ways of stopping it as we move ahead.
I fully agree with that. So then?
So, well, I don't want to repeat as has been just said. So just to supplement, in terms of research, I see that we should accelerate the innovation cycle, and I welcome advanced computing, artificial intelligence, machine learning. We need to be faster, lower cost, lower resources. And then in terms of what I expect from the Clean Hydrogen Partnership is, of course, it's part of your mandate. That means ensure that you have a high quality program, focus, adequate funding, along with the focus item that we all explained today. Additionally, as Deborah mentioned, it's very important, the link between the academy and the industry, I think is crucial. And for this new area, I would suggest really linking the hydrogen industry with the recycling industry. And I think we can move faster and forward. Thank you.
Okay, thank you. So we are almost reaching the finish, but we can have 5 minutes for getting questions from the audience. There is one question over there. I don't know.
It might be a mic around the room, otherwise I will bring it mine. A mic? Yeah, it's coming.
Yeah, just a minute and the mic is coming.
And very interesting discussion, and very happy to hear exactly the focus on those points that probably our program is not so much focusing, because I showed previously the economics, the environmental, but I think the discussion went a bit on materials criticality, the circularity, recycling, and to some extent as well the public and the society, and this maybe will need to be further investigated. We have a mic. Michael, please. Yes. Introduce yourself, please, first.
Good morning, everyone. My name is Michael Fickenschild. I'm a senior consultant at ECORIS, a research consultancy based in the Netherlands, and we are also helping the Clean Hydrogen Partnership to coordinate the European Hydrogen Sustainability and Circularity panel. Well, my question is on circularity, so many thanks for this discussion. This was very interesting to listen to. I feel like we're focusing a lot, though, in this discussion on recycling. We're focusing a lot on reducing, so two very important aspects still, of course, reducing material use, recycling materials, but there's of course also repairing, extending the use, extending the lifetime of products. So my question to the panelists, maybe especially to Eugene and Isotta, is what your companies are doing, working with your customers to extending the life cycle of your products, helping to repair products and extend their life cycle. Thank you very much.
Well, shall I? As I mentioned just before, and this is very important, and this is maybe a struggle if you think about the fuel cell stack, the disassembly and the utilization of the cells, the cell for the battery. I think we have to reconsider the design in a way that you can really disassemble, separate the components, and have a effective, high-quality recycling that is very crucial then for the utilization. I expect that if we own the stack as automotive, we own the stack at the end of the life of the vehicle, then we can really benefit and get the most value out of it. So we need to also change a bit the business model, not ownership, but sharing of cars, and where Toyota is, for instance, leasing cars. So this, we need to change our customer behavior. And then we would be able to handle the value chain and the opportunity of getting value from the stack at the end. But I agree with you, we need to make a product that more durable. Then durable means also more platinum, probably, thicker membrane, or we have to improve the materials that we have. But we are studying in Toyota how to increase the durability of our components. Now, maybe I have not explained earlier, but we have developed a stack for automotive, and we see that the opportunity to go into like heavy-duty trucks where the requirements are kind of different. Durability, I mean, is triple. I mean, the requirements are more stringent. So this also, as I mentioned earlier, there are some challenges ahead. Of course, there are opportunities, but we need to be aware that there are a lot of things to be solved on the plate, so we cannot do by ourselves alone, so we need a collaboration with many partners here.
So in working with partners, we absolutely try to emphasize that the benefits the economic benefits there are about thinking about longer term life cycle of the business. So maybe through a single machine to thinking what happens next, to how you recycle the machine, how you make it more long-lived. But also, I think things can be very different. So thinking about fuel cells, where often a fuel cell is designed to last the lifetime of a vehicle. If you think about electrolysis, for example, you're talking about industrial sites which can be designed to last through many iterations of a single stack. And so the approach is very, very different. And absolutely, I think many partners need to cooperate so that, for example, we focus on the chemistry of the catalyst-coated membranes that are going into these, while our partners are working on the mechanical engineering and design of the stacks and the balance of plant. Those can work iteratively together to give you the combination of durability and recyclability that will give the best environmental and economic output, but only through close collaboration. And clearly that also gets influenced by the regulatory environment and how long-term one is obliged to think.
I think we have time for one more question. I see one in the audience there, yeah.
Yes, thank you very much for this session, very important topic. I would like to continue the comment given by Deborah regarding to the importance of material research. And another track for the electrolysis and fuel cell is using hydrocarbon-based membrane, which is a replacement of a fluorinated membrane. And I want to see many process and production design are based on the material itself. For instance, the recycling technology, depending on which material are involved in the CCMs. If we change those material, the rest of the technology have to change as well. So what's your opinion regarding to the hydrocarbon-based membrane? How realistic is going to play an important role for the fuel cell electrolyzers? Because that's going to be important for many industries, including recycling. Thank you.
I can say some words on that. First of all, I think that we need to vastly accelerate the research that we're doing in Europe on that topic. There has been an opportunity recently But I think that if there's not more funding investment nationally and European levels, then I think we have a risk of falling behind with regard to what's happening in other areas of the world. And you know, we're in a bit of the situation at the moment, I think, where we have European industry that are involved in DOE-funded projects because that's where, you know, that's where the funding is, and insufficient funding in Europe. And the research organizations are then not being involved in that research with the industrial partners, at least at European funded project level. So I think there's a message there that hopefully will be heard. Obviously, you know, to be dependent on other areas of the world in whatever it is a vulnerability. And if decisions are made in the future where we need to move away from fluorinated membranes, then I think we need to have a certain degree of independence in that regard.
I think we are approaching the end. We have exactly the time for a last final remark, less than 1 minute. And in this, maybe from the panelists, a key priority. One word as you see for us in general, but think about one key word as you see for us priority. Concluding remarks, less than 1 minute. We can start from Isotta, maybe. If you need to add anything else, what?
I have many, so I will just talk about alternatives to fluorinated membrane. I just said a keyword, right?
So I think it's important for the industry and the Commission to pan out, think about a whole system, and not to look to isolated bits of it. So, for example, the link between fuel cells and battery electric vehicles. Doing one of them makes the other a lot easier.
Yeah, the consideration of exactly the topics that we're talking about here, and broaden it out to the whole critical raw materials, the supply chain, to ensure that we don't have those dependencies and vulnerabilities. And in terms of research topics, then hydrocarbon membranes and reducing and improving what we can get from iridium.
For me, it's about value. So everything we've been discussing is a high-value manufacturing challenge, be framed as an opportunity. We're in a continent with a huge amount of expertise and capability in those areas, and I have the luxury of not needing to worry about how tricky it is to do all that. So I can say it's an opportunity and it should be seized.
Thank you very much. I think we are approaching really the end of this session. I hope you found it interesting. Many insights. I took some notes, and I think I have the impression we're somehow at our partnership on the good way. There are many things that still needs to be done. Research is important, innovation is important. We heard many things about innovation on different aspects. I would like to conclude this session. Please don't leave. We are going to have a small break. At 11, the session will continue with the prenovative research managed by one of my colleagues. So a small break, and please a warm round of applause for our panelists. Thank you so much for being with us. Thank you.